So this should be the final video with making a regular singly linked list. I'll leave the tail for other videos. I might just incorporate that fully into a just the doubly linked list. But a singly linked list can have a tail, okay? And if you have a tail, that means we do have to have two more conditions in both our add and remove method. But for right now, I just want to keep it simple, so we're going, and this works perfectly well. You don't need to keep track of the tail. Okay, so right now, we are removing any other index from a list, from a linked list. So here's what I'm going to do. I am going to go ahead and label these guys again. And remember, these guys, this is going to, just like adding to a random place, these guys are going to be at random locations. Some random, or not random location, but at some given location that's not the beginning or end of the list, or beginning of the list. So we've got we've got I minus 1, here's our index I minus, the node at index I minus 1, index I. This node is at index I plus 1, and I plus 2, and so on and so forth in this direction, so on in this, and so forth in that direction, right? Okay, and obvious, and should be fairly obvious which one I want to remove. I want to remove this guy at index I. That would make this index, that would make I plus 1 the new I, and I plus 2 the new I plus 1. We're going to remove I. So how is that going to look? Well, in the end, it's going to look like this. It should look pretty much like this. Okay? These arrows have a really small, those boxes are really small to hit. Alright, it should look something along those lines. Okay? So the question is, how do I get from here to there so I can remove this? And this will be this will then turn into I, and this will turn into I plus, right, this will become I, this will return I plus 1. So how do I get there? Okay? So the way I get there is just like I said, the add move and the remove method, the add method and the remove method, they're kind of symmetrical. So because we have to get, remember what we were doing? We were creating we had a node. Whoops, I don't need word art here. We had a before memory location. Before. Right, and it pointed to and this was storing the memory location of the node before the one we want to remove. Okay, now we're gonna use that same concept here, right? Because we can't just, if we went and got this guy, right? If we went and searched for this node, we can't just yank him out and remove him, right? Because yanking out and removing him, I can't tell the guy behind me that he should attach the guy in front of me. So I have to get the guy behind me so that he can directly be told what his new attachment is. Okay? So the first thing we're going to do is that we are going to we have to do two steps first. Just two very basic stuff. You may have guessed what well, the first thing I need to do is I have to get the location of this guy. Well, sorry, this guy of I minus 1, right? In order to get to here, I have to get the guy before me because I need to be able to manipulate this arrow. I need to be able to manipulate the dot next, his dot next. Okay, so let's see, that is get node at index minus 1. Now you may have asked, well, why doesn't this ever go, isn't this a risk of going out of bounds, index minus 1? Couldn't that bring me to like index negative 1? And the answer is no, actually, because of this condition. Because we're at because we have an if statement that activates over here that's index 0, this only goes on for indices 1 or above. So that means that the smallest value for index in this line is 1. So we aren't at risk of going out of bounds there. So node E before. Okay? So then I also have to make sure I store the item that's located at index I. So this will give us a hint to how to complete the next step. Alright, so we need to store into return the item that's located at index I, at this node. Now this node over here is before.next. That's how we get there. We go there by going through before. It might be better if I'm rather than, and for some of you it might be clear if rather than having an arrow there, I just kind of drag this on and say that's before, right? Before, right? Dot next gives me the guy at index I. So what am I gonna? So what do I do? Well, this is before. This is before.next, and the item inside this node would be before.next.item. Okay. And now we just basically need to. So now what do we need to do? Well, actually, all we have is one step. What we need to do is go from here. Okay. What we need to do is from this, go from having an arrow there to having an arrow there. I thought that would line up better. Yeah. To boop, boop, boop. Nope, doesn't look that great. But basically, we go from pointing here to this node to pointing to I plus 1. Right? We need to make sure that the arrow goes from, stops going from here. This is where we start at. Instead, what we need to do is take this arrow and have it point over here instead. And what will happen then? Well, then this guy won't have anything pointing at him, right? He's going to have nobody storing his memory location, so he'll get deleted. And that will remove that variable over there, but these guys won't get deleted because I minus 1 will be pointing to them. Okay, so what we need to do is we have to go from pointing this arrow over to here, from here to here, right? So that arrow is represents before dot next. Okay? So what are we storing in the memory location of before.next? Well, right now we're storing in the memory location of before.next this node, which is before.next, right? And we want to store this item, this node in there. So what is this node? This is before. This is before.next. So what is this guy? Think about it for a second. And if you answered before.next.next, you are correct, right? Before, one step, two step. Okay? So, what we do there is we go before.next is equal to before.next.next. Okay, this is where it gets, where I typically lose people, but it's very vitally important you understand what's going on here. Okay? What we're doing is that we're taking the memory location of this node, before.next.next, and storing it in here, in the .next arrow. We're taking the memory location on the right and storing it in the variable on the left. Right? This gets resolved into a memory location. We take this memory location and just store it in before.next. We store it in what's represented by this arrow. So that will happen. And then nothing will point at that. So it's very vitally important that we do it in this, that basically we get the item before the node we want to remove, so that we can do this manipulation. So, and again, this node is before. This is the item that comes after. This is the node that comes after it. So this node is before. This is the node that comes after it, before.next. And the node that comes after that would be before.next.next. And this guy would be before.next.next.next, but there's no guarantee that this one will really be anything that we can get to. So what we did is that by storing the memory location before.next.next in before.next, we essentially skip over this guy now, and he'll get deleted. Alright, and then this guy will be, that makes this guy I, and this one I plus 1. All right. So what happens if we want to delete the last node in the list, right? Does this still work? And the answer is yes. What we'll do is we get the last node. Let's say that I plus 1 is the last node in the entire linked list, okay? So we get the item beforehand. And what do we do? This was before. And what we're going to do is we're going to grab the item out of here, and then we're going to say before.next is equal to before.next.next. Now .next is null. Now this .next is null, so what we're doing is saying before.next.next, which is a null, gets stored in here. So, right? So that's it for this video. I'll go over this one more time with the code side by side for this, but if you understand this, you can go on to the next video. But I'll go ahead and just lay it out one more time in case you're not following. Okay? Because this is the trickiest part. Once you get this, everything else it's easy. Once you can get this, you're fine. You're good. You're basically good for for basically the overhead you need to succeed in this class. All right? So say again we want to remove the node at index I. What we do is we get the node before index I. So that's this guy. So we'll say that this guy is before. Okay? So we get the node before the guy we want to remove. We retrieve the item from this index. So to return, it stores before.next.item. Before his .next. This is the .next. This is the item stored in .next. Okay? So we grab it and store it to return, which is not shown here, right? Because this is just drawing the nodes, not the items inside it. And so now, what this does is that we take before.next.next. So before.next.next. We take its memory location and store it in before.next, which means what we do is that we update this arrow to point over here. Now, because there's nothing pointing at this guy, this all happened in like one simultaneous move, this guy gets garbage collected, and he no longer is in the list. Then we do size minus minus, and we return.